Hello everyone. So today we are here with one more data set, and that is flight data, where we have we need to predict the price of a flight. So first we'll do a basic stuff with that data set, a bit understanding how the meaning of different columns and how to clean those columns if required, to add some more columns, how to do it. And then after EDA we will be doing some visuals we are going to create, and then we'll use this data set to predict the price of a flight. So that's not a very big data set, small one with a few columns are there, not so many columns I have used. So let's start with this only. So first we need to read this. So let me create a new notebook, and here let me give it a name, project flight fare prediction, right? So this is what we are going to do. Okay, it's not going to take this, so let me rename it. So first we basically import the required libraries. So let me import numpy as np and pandas as pd now. Later, if required, we can import some other libraries as well. So the data set is to this location. Let me copy this path. Here it is. And the data set name is flight underscore data. So we are going to read it. Read underscore CSV, because that's a CSV file. And we simply paste the path / flight underscore data dot CSV. So that is going to give a Unicode error. So we are going to mention R and we are good to go. So here is the data set. Let me put head so that we can see first 5 rows. Here it is. So here we have airline, the different airlines. We do have the date of journey and the source, the destination and the route that they followed, departure time, arrival time, duration, total stops, additional info and price. So these are few columns are available. So first let me check the shape of the data set so that we can get the idea that how many rows we do have in columns. So we have total 10,683 rows and basically 11 columns. So here let me check the missing as well. So whether we do have missing or not. So we need to deal with this. So we have missing data as well. Not so many, there are only 2 records are there which is missing. So let me directly drop it. So if we have the data size of the missing records is higher to all the columns, so we require imputations as well, but here we have very less data as a missing value, so we can directly drop it. So we are using a drop NA and with in place equals to true. We did it, we run it, and again we can check whether we have missing or not, just to validate it basically. So is null and then sum, and we run it. We see that now we have dropped all the missing records. So we validated that part. Let me run it. Let me check the info of the data too, so that we can get the idea that the number of columns, the data types and all. So we have these columns, mostly columns are the object one, apart from the price that we do have here. So this is now, let's quickly jump into the EDA part. So what we are going to do in EDA, basically what we noticed here, so we have one column date of journey, you see here, date of journey as an object. So the values that we do have, let me put head so that we can see those values as well. So these are the date values. So we need to convert this as a date and time if we do some date specific manipulations and all. And then we have date of journey, and one column is as a date. I think this one is the only column as a date, right? So what we are going to do from the date of journey, let's do one thing. We can extract the day and the month. These two we can extract. So what, let's write, let me write it here. Let's replace the column name date of journey, let me copy and paste it from here only. With separate column as journey day and journey month, so that we can have a idea like on which day that journey has made and what was the month. So we can use these two columns later as well. So to do it, what we can do, first we have to convert that into a date time column, right? So, and what we can do, let's say pt.to_date and time is a function that is required to convert any date time column as a date and time. So what we can do, the data frame name and the column name. What is the name of column? Let me copy and paste it. So here it is. That's the column name and the format that we want. So it's up to you in which format you want to put it here. So I can put it in day, month, and year. So let me give the idea. I mean date and / I think maybe we can have error, but let me run it and check why. Okay, so why let's take it in a caps, and then we are going to extract. We can create a column from here only. So let's now it has been converted, so dt will get activated and then we can extract day from here, and then here only we can create another column to put that value into that column. So that column, you can have a name something like this. What journey day or whatever. I mean journey day we can have, right? Journey day. Perfect. And the same we can do for month. So let me copy and paste this and I'll do the modification for the month part, right? So here the format will be same. Apart from day, we can have a month here, right? The column is same and journey day should be journey month, right? So what we are doing here in these two lines of code, first we have converted this column to the date and time, and the format we have put it the DDMMYY kind of, and we have extracted day from there, and we have extracted that value and stored it to a new column which is journey day. And the same we did for month. We extracted the month part and stored it into a journey month. And if we run it, and we can check the head here and see what is the output in these two columns. So if we see, that was the date and the day was 24. I mean basically what was the day, and you could say is as a date as well. And the journey month was 3rd, so we have extracted that from here. And here as well, this is 1 and 5. So we have extracted the day and the month from that date and time column and created new column. So this is what we did. Now, next what we can do, basically, we have departure time. So the time column that we do have, what we can do, this is into the form of hour and minutes, right? Hour and minutes, I could say. So we can do some, manipulation to that column as well. What we could do, so we can create departure hour and departure minute using the departure time column. So basically we can separate it and further we can drop this column. So by using this one column, we have created 2 new columns and then we can use those later, right? So let me write it. Also create departure hour and minute. Departure hour and departure minute from departure time column, right? So how we are going to do it? So pd.to_date and time is required to convert that into date and time. And the name of the column, that is, let me copy and paste. I always prefer to copy and paste the name of the column. And now we need to extract the R from here. So we can directly extract R because that is there. And then we can store it to a different column. So we can create that column here only. Basically the df and the column name, and then we can assign that value. So that will be a departure R, Right, perfect. So let me copy and paste. So we can create a departure minute as well. So in place of hour, we can have minute. That is full minute. After DT, once DT get activated, we need to use minute to expect the minute part. So these are the date time functionality. So we run it. So now again, let me check the changes that we made with these two columns. Sorry, I have to put 2 into those parentheses, right? So here we created day hour, departure hour and departure minute. And we see we have created from this column departure time. So that was 22. So that is 22 hours and 20 minutes. So we have separated that here because, you know, that column was there. So we could use it, but still we have, basically we want to do some manipulation using hour and minute. So we have created these 4 new columns using these 2 existing columns. So now we can drop these 2 existing columns from the data set. So let's drop those. Now we can drop, what was the name? Departure time and journey date, right? Date of journey. Date of journey column. So how we could do it? Data frame dot drop, and in columns we can mention the, in a list we can mention the name of the column. So let me copy and paste that. So that was the date of journey. And then the other column that we want to drop, that is departure time. So let me put it here. And in case we want to make changes to the master data here, so we have to put in place equals to true. Don't forget it. Let me give you the idea that if we don't do it. So here we can see that these 2 columns are not available, right? And if we again call df here, so you will see that these columns are here. So they don't get deleted. Oh my God, I again write 2 here. That should be here. So see, these are here. But if we use in place equals to true, so that will actually delete from the master data. Otherwise, you can create a new variable or object. So once I run it and then I call it df head, we see they have been deleted from the master data, which was df. So we don't have those date of journey, arrival time. Sorry, arrival time also we could delete because that doesn't make any sense. So no worries, I can drop it here too. Okay. Columns equals to, in single, I can pass arrival time, because that is not in a proper format. So we required a lot of cleaning. So better to drop it. And you know, we have the time available, which is something, somehow we are not going to use it, let's say. So I can put in place here, right? And I run it and I call my df again. So we have airline, we have source, we have destination, we have route, duration, we have total stops basically, additional info, we have multiple things all together. So what we can do, basically, you know, the time that we take to reach to the destination, we can consider as a duration. And you know, the difference between the departure time and the arrival time. So the difference between the departure and arrival time is basically the total duration that has been considered to reach from one place to another place. So what we can do here, we can do something using the duration column. So let me, you know, first let me convert the duration column into list. Okay, I'll explain you. Let me do it first. Let's convert duration column into list, or you can create a list of durations. This is what we can say. So the duration that we are going to store, and we can use a list predefined function, and we can extract duration from there. So D is in caps for duration, right? Or we can write it in square bracket as well. And now let me check the length of duration. So I can get the idea, the total records I do have, that should be equal to the shape of the data. So that is 10,682. And what type of value we do have under duration? Let me check that too. Let's say for, okay, that is 7 hours 5 minutes. So something like that only. If we check the 0 index, that should be 2 hours 50 minutes. Perfect. So we have created a list of all the durations. Now what we are going to do, basically, we can apply a for loop to the length of the duration, and we can check that if we don't have this shape like this, we are going to split it based on the space, and that should have the length of two variables like 2 hours 50 minutes. So might be we have some data which is not into this kind of format. So basically we can add 0 minute into this. Might be we may have a data something like this. Let me, basically what I could do, I can check the unique of duration as well, so that I can get the idea. Unique. Okay. See that we do have some values here as a R only, and we have here as well, right? So we have to deal with this because this time we have only hours, not minutes. So wherever we have only hours, we can add 0 minute into that, so that we can have a same format. You see that 5 hour is here, 10 hour here. So that is not a proper hour and minute format. So we are going to basically do something so that we can have a similar kind of hour and minute format. So to do this, what we could do, let me, and unique, total 368 unique records are there into that duration column. So what I can do for I in range, and we can apply that to the length of the duration that we have created. All right. And what we could do, we can check if length of duration, that was our variable that we have created, length of duration, we can apply I, and then we can do dot split, and we are going to split it on space, and then that should not, wherever we have value which is not equal to 2, the length of the value not equal to 2, what we are going to do, okay, and not equals to 2, but still we have R there, so we can handle, might be somewhere we have only minutes, so we can handle that part here only. So we have R, and one thing that you need to remember, might be in our data we have R in lower and upper cases as well, so we need to convert that into the same cases. Here we notice that was into the lower cases only, so that's why we have applied condition on the small h, the lower case only, right? So that you need to take care. So on the duration I, what we could do, if the length not equal to 2 and we have h in the duration, then what we can do, okay, duration of I, let me run it. Okay, duration of I dot strip, that's what we can do. Might be we may have some extra spaces, so we need to strip that, and then we can simply add basically 0 minute, right, with some space. That's what we can do like this. And here I can write adding 0 minute to have a same format, right, something like that. So in case we have basically we can apply another condition. If we have m in the duration, right, okay, if we have m in the duration, then what we need to do, duration might be we have only we have values with minutes only, not with hours, although we haven't noticed, but that is also a chance. And here we just go through with this data, but sometimes it happens that we have very huge amount of data, but we are not able to look into that property, right? So something like that we could do, dot format we can use here, and then using duration, okay, and again we are going to strip it, So this is what we did here. I hope it's clear that what we are going to do it. We have applied a for loop to the length of the duration to check whether if we don't have the length of the, after splitting that with the space, if we don't have the length of that string, which is not equal to 2, then we check again that if we have h, then we are going to add 0 minute. If we have minute, then we are going to add 0 hours into this, right? So this is what we can do. So let me run it. What is the mistake I made? Aleph M in duration I. Okay, sorry, in the duration, sorry. I was speaking and writing, so that should not be there. Okay. Now, what we can do, we can create a separate list. Okay, separate list for basically duration hours and minute. Duration hours and duration minutes. So we can create that list, something like that. Duration hours. That's this list that we have created, and then we can use duration minute. Fine. List we have created, then what we can do, then basically we can extract hour from the duration and we can extract minute from that duration, and then we are going to store it to that list, which is duration hours and duration minutes. So how we can do it? We can simply apply a for loop to the length of the duration. First we fix that. Now to the length of the duration we applied for loop, and then we are going to append it with duration hours. Okay, no, not hours, that is only hour. We can have hours. So let me correct that here too. So duration hours we are going to append, and we are going to append that with duration dot split, because duration part will be coming as a 0 index. So first we split it, maybe we have some extra spaces, then we pick the 0 index. From 0 index, and then we have basically all, we are going to reverse it till -1 basically, and we can convert that into an integer here only. So what we can do, we can write integer here and we can convert that part. Perfect. The same we can do for minutes. So let me copy and paste this line of code only, and I'll modify it. So what we can do, duration minutes dot append, and here we have to take the 1 index, right? And I am writing it here to extract R, and this part is to extract minutes from name of the column was sorry, the duration, right? So this is what we did. So let me run it, and now we can create a new duration hour minute columns using that above list. So let me check what data we do have into this list. Let me run it. Yes, so we have extracted all the minutes, and we can check for the hours as well, just to verify. Yes, so we have basically extracted hours and minutes from there. Now we can create a new data frame using that part. We could do it in another way as well. That's one of the approach. Now we can create columns using above list. Right, so I've added the comment here as well. So the name of the duration, that the column name we can create duration hours, right? And the value that we are going to put it here, that is coming from duration hours list. Perfect. And then the same goes for the duration minute. Duration minutes, and that value also coming from that list, minute list. Perfect. Now let me run it and check whether we have added these two columns or not. Head to. So let me do it. Duration, hours and minute we have added, and if we see that we have extracted that from this duration column, so 2 hour and 50 minute was there, and we see the 2 and 50, we have stored that into another 2 columns, so 725, something like that. So we can that verify as well, right? So we now what we can do, we can drop the duration column as well. So let me drop it here, drop, and here I can let you know the another approach to drop the column. The name of the column was duration. So without, if in case we don't add columns like we did previously, we can use access equals to 1. So access equals to 1 and then in place equals to 2. Access equals to 1 means column wise, you want to perform any operation as a column, and in case you mention access equals to 0, that means anything you want to do on a row basis. So here again, let me check the data frame with 2 rows. We see that duration column is not there, so we have dropped it. Now what we can do, let me check that how many unique records we do have under this airline column. So how we can check the unique records and their occurrences? Unique records and their frequency in airline. How we can check it? The data frame, and we are going to select the name of the column, which is airline. And in airline, what we need to do, we can simply apply a value count. So we can get all the unique records with their frequency. So we can get the idea that how many unique airlines are there in that basically airline column and what is their frequency. So we see that we have very less value for Jet Airways and for Vistara and for 2Z, but and we can see multiple carrier as well, but we have good amount of data available for Jet Airways and Indigo, Air India and something like that. So we can see that what we can do, we can apply a dimensionality reduction technique here so that we can reduce the number of airlines that we do have. So there are multiple ways to do it. What we can do, we can make like wherever we see that any airline with where the number of occurrences of any airline which is less than 20, 15 or let's say 13, any value that's up to you, is less than that, we can put it into a other category. This is what we can do, right? So to do it, what we can do, first we are going to strip it, and to strip it, what we can do, basically, let me minimize this. How to minimize that part, right? So here it goes. The data frame and the name of the column was airline, and we can apply the lambda function so that we can strip the extra spaces from there. I can do it something like that, right? And then dot apply, and then we can apply a lambda function here, and that lambda is lambda x colon x dot strip, and we have stripped all the extra spaces from this column. What next? We can create a airline stats. Okay, and we can basically put all the value counts in the descending order into that. So to do it, what we can do, df dot airline, right, dot value counts, and that should be ascending equals to false. So we can have in decreasing order, although by default it put in decreasing order only. So we have created the airline stats here, and now we can apply dimensionality reduction here. Basically we can reduce the dimension of that column. So we can basically, wherever we have that value less than 10, okay, we can put it here, airline stats less than equal to 10 or you can have 13, it's up to you. I'm taking 10 here, but still we see that we have 10 value was there. So it should be like this, right? So we will be having some values where we have this value less than this. So we are going to store it. We have three values where the value is less than 10. So we can store it less than 10 variables in another variable, right? And we can directly apply a lambda function on that column, df.airline dot apply, and in lambda function what we can do, wherever we get any value which is less than these stats, we can make it as other. So if xn, let's say airline underscore stats underscore less than, let me copy and paste it only in, right? If xn this value, then we can make it other, otherwise return the value something like that only, and then we can directly store it to that column. So the name of the column is airline, and here it goes. So once you run it, and if we check the unique records to the airline column, now you will see dot value counts es, we see that we have put it that into the other category. So everything which was there previously, we were having some more values like Jet Airways, Business, TrueJet and all. So now we have put it all three into the other category. So why we did it, basically, this is the unlabeled data, and once we are going to create a machine learning model, we need to label it, and to label it we have to create, let's say we are going to do a dummy variable trap. So we will be having the number of columns based on the unique records we do have under that airline column. So under that airline column, if I apply n unique, so we have total 10 columns, and previously we were having 12 or 13, I think. So this is just a one case, sometimes it happens we have value which is less than 10 and the count of those values is, let's say out of 200 categories, that is 50. So we reduce 50, we make all the 50 into one category. So that is how we use to reduce it. So to reduce it, we need to check the occurrences of those particular values. So that doesn't make sense, because out of 4,000, 3,000, we see that that particular airline was coming as a once or twice or thrice or 6 times to the entire data set. So we can put all the values into one category and make it as other, or you can give any name to this. And then all the values will be coming to one category, and then we will be having one column only. So the use of dimensionality reduction is this. So that is quite helpful. So this is what we did here. What else we can see, that we have one route column. Let me put head again so that I can see we have one route column. So we can see that what type of value we do have into that route column. Route, if we check, so we see that we do have values something like this. Might be these are some, the short name of these locations, and then we have put it as separated by the columns, and we have one more column. Let me put it as head. So we have just one. We have one more column. I just forget the name. Basically the additional info we have, right? So let me check how many records are we having that under that column. So additional info, and we can apply the value count. So we can directly check the unique record with the frequency. So we see most of the values under that additional info column as no info. So total 8,300 values are something like this. And we have other values as well. Let's say in-flight meal not included, no check-in baggage included, one long layovers, something like that. We have some additional info column having some more information about the flight. So we have these values. So there is no sense to have that data where we do have that information. If we have if we want to deal with this, or we want to have it, we can do it that too. So with no info, we can have total like approximate 80% of the data in that additional info column is like no info. So we can drop it, right? So what we can do, we can basically drop that part. That's what we can do. And for route, we can check that how many records are there, the route as well. So we get the idea of that column too. Then we have total stops. We need to check that how many total stops, that one stop, the two stop, four stop was included. Or we could say that, let me run df.head so that all together we can see the name of the columns as well. Right. So I was talking about the total stops. So in total stop, we have so many records. In route value column, we have so many records. So what we can do, we don't find that these columns are quite important and all, or the route and the route column that we have created, that is also related to total stops. So they are related to each other. We can remove route column from the this data frame, and we can remove the additional info as well. So let me check in additional info. I don't find that is a very meaningful information, which is going to help us to predict the price of the data, price of the flight. So we can drop that, and we can drop the route as well. So how we are going to drop it? df.drop, and we can simply use columns equals to, and in a list we can pass the name of the columns that we are going to drop. So we are going to drop the route and the additional info. So in real time scenarios, when we are going to add or drop any values, we need to discuss to the business owner or the subject matter expert to get that idea, right? But here we can directly drop it. So now if we check the head of our data again, so we have these 3, 4, 5, 11 or 12 columns we do have in this data. We have airline, we have source, we have destination, we have basically price is also there. We have so many columns, right? We have created those columns, something like that. So what we can do now, these columns that we have created, right? So, okay, what next we can do with that data set? We need to label it basically. We have unlabeled data, so we need to label it. So, okay, so no, because route was there, additional info we have put it, total stops. What we can do, we can label it. Let me check the count of total stops. So let me copy and paste it. Dot unique. So how many unique values? We have non-stop, 2 stop, 1, 3, and 4 stops. If we check the value counts, so we have 1 stop, it was occurred 5,600 something time, and then we have 1, 2, and 3, and 4 stops, something like this. So what we can do, we can basically, it's kind of an ordinal category. Ordinal, basically that 1 stop, 2 stop, 3, 4 step, they do have some mathematical meaning. Like if we are going to take any flight, so how many stops we do have before to the starting point and to the destination point. So that also makes a difference. So we, we can directly give it some labels. So what we can do, total stops is a ordinal categorical column. So we will label it. So how we are going to label it? We can simply use a dictionary format to label it, to replace all the existing values. So we can use replace, and what we are going to replace? Basically, wherever we have non-stop, non-hyphen stop. We have to pass it like that only. We can make it right. Okay. Non-stop, we can make it 0. Right. And wherever we have one stop, let me copy and paste it. We can make it 1. Fine. And wherever we have 2 stop, so just convert 1 to 2. We can make it 2. And wherever we have 3 stop, 3, that is stops, 2 and 3 stops. We have to add S as well. Right. So we can make it 3. And we have one more stop value, which is 4. We can make it 4. Fine. So we have converted this, and we need to basically, that should be in a dictionary. So we have to apply a curly braces here, and then we can pass in place equals to true to make the changes to the master data. Right. So we're done with this part. What else we can do? Now, if we check the total columns, we have airline, we have source, we have destination, price, journey day, journey month, departure hour, departure minute, duration hour, duration minute. I think we have dropped the arrival. I think that column was also there, I think. Let me quickly check that. Yes, so we had our arrival column too. In case we don't want to drop it, we can have it. Or in case you have dropped it already, so that's okay. You can have, basically we have our okay. One thing that what we can do, we made a mistake with the arrival time column. We can basically create the arrival hour and arrival minute like we did for departure. So let me rerun that code to fix that quickly. Just a moment, because otherwise we can take it that way too, but let me include the arrival time as well, so that we can do the same thing like we did for duration and all. So here if we see, now we have arrival time too. So these are the total columns that we do have. So for the arrival time, we can hope you remember that how we did for the the duration column, we can do for the arrival as well. The departure hour and departure minute we can extract from there. So let me do it using arrival time. Create new column as arrival hour and minute. Exactly the same that we did for the departure. Hope you remember. We discussed that. Like this. So we just need to rename the name of the column and we are good to go. Let me put it there only. So you guys could do it in a starting, because I just missed that part. So I can do it here. So in place of departure hour, we can have a arrival hour and we can have a arrival minute. Right. And here we can have a arrival time column that is there. So let me copy and paste it. Perfect. Here. And we can paste it here. Sorry. Control C and V. So now let me call the head and Oh my God. It should be like this. So we have, journey day, journey month, departure hour, time, duration hours, duration minute, and we have arrival hour and arrival minute. Now we can drop that arrival column. So because that is not required for now, we have created one new column using that. So we can drop it here, drop, and we can simply use columns equals to and the name of the column, which is arrival time. So that's it. Oh, sorry, we need to put in place equals to true as well. Right. So here it goes, and now we can check again what is the changes. So we see that arrival time is not here now. Now almost we have all the columns as labeled apart from these three columns, which is basically the airline, source, and destination. So what we can do, basically we can create a dummies data for this. So how we can create it? We can use a get dummies function. So pd.getDummies is a function which is available there in pandas, and we can pass the name of the data frame here, and for all the columns where you want to apply it, you can pass those columns in a list. So we have to do it for the airline, so that should be here, and we have to do it for source and destination. So let me copy and paste it, source and destination also. So it will create all the columns under this as a unique. So we can directly drop off first occurrence of that dummies columns here only. So I have used the drop first to. So what drop first to does, let me explain you here. For example, under airline column, we have 4 categories. Let me use a notepad so that you guys can have a better idea. Right. So for example, under airline, we have, let's say, 2 category, Air India, and we have basically Indigo, for an example. So after applying, after get dummies, what we are going to do here, get dummies will create 2 whatever we have this values under that column, 2 new columns. So the one column will be airline and the other column will be Indigo. Right, and the values we will be having, let's say the first record was related to airlines, so the value for airline would be true, and for Indigo that would be false. And let's say the another value was for Indigo, so this time we have 0 for airline and 1 for Indigo. Basically, in one time, one airline can only belongs to one category. Either it can be airline or it can be Air India. Sorry, not airline. That should be Air India. Let me correct it. Right. Either it can be Air India or Indigo. It cannot be Air India as well as Indigo in one time. So what we can do, let's say we drop one column from here. So let's say if we have 0 in Indigo, we can understand that that value belongs to Air India. And if we have 1, so that belongs to Indigo only. So that's why we can drop one column from all the unique columns that we have created using getDummies. So either you can drop first or last, it's up to you. We can use a drop first. So this is going to drop all the first columns for the dummies data that we have created. So, and let me put it here, df and dummies. So we have created this. Let me call or run dummies so that we can get the idea. You see that we have total these columns that we have created now, we rename that, and all our labels here. So the number of unique records that we do have under all the categories we have under this. So we have 10,600 something rows, that is equal to the previous data. But this time we have basically increased the number of columns, and that's totally depend on the unique values that we do have under these 3 columns, like arrival, source, and destination. right? So now what we can do, now we can basically extract the dependent and independent feature from here. So how we can do it, that was our data frame. Let me copy it. You can run with head only here. So what basically we need to predict the price. So price will be your dependent variable, and apart from price, all the values will be your independent feature. So independent features. So what is your independent feature? We put that into a X, and in X, what we can have, that is your data frame. And in data frame, apart from price, we want everything. So we can write drop price and take cost. P is in caps. Right. And that's how we want to do it on a axis one. So we can mention the axis as well. And for Y, what we want to have? For Y, we just want to have one column, which is price only. So this time we have extracted not V, that should be Y. Let me rename it. So if we see our X, we have basically all the variables. And if we see Y, we have only price variable under this. So this is how we have created our dependent and independent. Now the next part is like we have to do, we are done with the EDA, and we are done with the cleaning of the data. We have created our final features. Now in next class, what we're going to do, we are going to build a model, and then we are going to split that data and create a model and verify it. That's it for today. Bye-bye. Take care.